Physicists may have found a fifth force. Whoa, that sounds exciting! And since it sounds so exciting, you see it in the headlines frequently. So frequently, you probably wonder how many of these fifth forces there are. And what's a fifth force anyway? Could it really exist? And if it exists, is it good for anything? That's what we'll talk about today. Before we can talk about the fifth force, we have to briefly talk about the first four forces. To our best current knowledge, all matter in the universe is made of 25 particles. Physicists collect them in the Standard Model. That's kind of like the periodic table for subatomic particles. These 25 particles are held together by four forces. That's first, gravity, apples falling down and all that. Second, the electromagnetic force. That's a combination of the electric and magnetic force which really belong together. Third, the strong nuclear force that holds together atomic nuclei against the electromagnetic force. And fourth, the weak nuclear force that's responsible for nuclear decay. All other forces that we know, for example, the van der Waals force that keeps atoms together in molecules, friction forces, muscle forces, these are all emergent forces. That they are emergent means that they derive from those four fundamental forces. And that those forces are fundamental means that they are not emergent. They cannot be derived from anything else. Or at least we don't presently know anything simpler that they could be derived from. Now, if you say that gravity is a force in the wrong company, someone might point out that Einstein taught us gravity is not a force. Yes, that guy again. According to Einstein, gravity is the effect of a curved spacetime. Looks like a force, but isn't one. Indeed, that's the reason why physicists, if they want to be very precise, will not speak of four fundamental forces, but of four fundamental interactions. But in reality, I hear them talk about the gravitational force all the time. So I would say, if you want to call gravity a force, please go ahead. We all know what you mean. As you can tell already from that, what physicists call a force doesn't have a very precise definition. For example, the three forces besides gravity, the electromagnetic and the strong and weak nuclear force, are similar in that we know they are mediated by exchange particles. So that means if there is a force between two particles, like say a positively charged proton and a negatively charged electron, then you can understand that force as the exchange of another particle between them. For the case of electromagnetism, that exchange particle is the photon, the quantum of light. For the strong and weak nuclear force, we also have exchange particles. For the strong nuclear force, those are called gluons because they glue quarks together, and for the weak nuclear force, these are called the Z and W bosons. Gravity, again, is the odd one out. We believe it has an exchange particle. That particle is called the graviton, but we don't know whether that particle actually exists. It's never been measured. And on the other hand, we have an exchange particle to which we don't associate a force, and that's the Higgs boson. The Higgs boson is the particle that gives masses to the other particles. It does that by interacting with those particles, and it acts pretty much like a force carrier. Indeed, some physicists do call the Higgs exchange a force, but most of them don't. The reason is that the exchange particles of electromagnetism and the strong and weak nuclear force, and even gravity, hypothetically, all come out of symmetry requirements. The Higgs boson doesn't. That may not be a particularly good reason to not call it a force carrier, but that's the common terminology. Four fundamental forces. Among them is gravity, which isn't a force, but not the Higgs exchange, which is a force. Yes, it's confusing. So what's with that fifth force? The fifth force is a hypothetical new fundamental force for which we don't yet have evidence. If we found it, it would be the biggest physics news in 100 years. That's why it frequently makes headlines. There isn't one particular fifth force, but there's a large number of fifth forces that physicists have invented and that they're now looking for. We know that if a fifth force exists, it's difficult to observe because otherwise we'd already have noticed it. This means this force either only becomes noticeable at very long distances, so you'd see it in cosmology and astrophysics, or it becomes noticeable at very short distances and it's hidden somewhere in the realm of particle physics. For example, the anomaly in the muon G-2 could be a sign for a new force carrier, so it could be a fifth force, or maybe not. There's also a supposed anomaly in some nuclear transitions, which could be mediated by a new particle called X17, which would carry a fifth force, or maybe not. Neither of these anomalies are very compelling evidence. The most likely explanation in both cases is some difficult nuclear physics. The most plausible case for a fifth force, I think, comes from the observations we usually attribute to dark matter. Astrophysicists introduce dark matter because they do see a force that's acting on normal matter. The currently most widely accepted hypothesis for this observation is that this force is just gravity, so an old force if you wish, but that instead there is some new type of matter. That doesn't fit very well with all observations, so it could be instead that it's actually not just gravity, but indeed a new force, and that would be a fifth force. Dark energy too is sometimes attributed to a fifth force, but this isn't really necessary to explain observations, at least not at the moment. If we found evidence for such a new force, could we do anything with it? Almost certainly not, at least not in the foreseeable future. The reason is, if such forces exist, their effects must be very small because otherwise we'd have noticed them earlier. So you most definitely can't use it for yogic flying or to pin your enemies to the wall. However, who knows, maybe if we find a new force, one day we'll figure out something to do with it. It's definitely something worth looking for. So if you read headlines about a fifth force, that just means there's some anomalous observation which can be explained by a new fundamental interaction, most often a new particle. It's a catchy phrase, but really quite vague and not very informative. This video was sponsored by Brilliant, which is a website and app that offers interactive courses on a large variety of topics in science, computer science and mathematics. All their courses challenge you with questions, so you can check your understanding along the way. If you need to freshen up your knowledge about forces, have a look, for example, at their course on classical mechanics. It covers all the essentials: forces, energy, momentum, pressure, and so on. It will give you a solid basis to understand modern physics. To support this channel and learn more about Brilliant, go to brilliant.org/Sabine and sign up for free. The first 200 subscribers using this link will get 20% off the annual premium subscription. Thanks for watching. See you next week.